Okay, so we're going to talk about in this short video lesson about absolute and relative addressing in low-level programming and assembly. Okay, and basically there are two ways of identifying the location of each instruction when it's loaded into memory in order to be executed. When we use absolute addresses, basically we are using the actual um, numeric value of a memory location. The problem with this, of course, is that the program has to be loaded into the same position every time it's executed, and that's probably not usually possible. So to get around this, we use relative addressing. Now, relative addressing is where we note the um, relative address in terms of say, for example, the first line of the program, the first instruction of the program. We would have that as the first location, and then we would calculate from that point any absolute address locations from that point and the relative address that's included within the instruction. So to hopefully clarify this, we'll look at a comparison of symbolic, relative, and absolute addressing. Okay, so looking at this example, if we look at the first example here, we've got the symbolic addressing, where we've got a symbolic address here. We've got the start, the loop, and the letter A. We've got these symbolic values that are used by the program, but these would need to be converted by the assembler at some point into absolute addresses. Okay, so we've got store A. Well, this tells us that we've got the start location indicating the first line of the code. Then we've got store A, and A is down here, as we see at the bottom of the last line of the code. Okay, so at any point we're using A in our program, we are referring to this position. Okay, now here we've got the indication of I suppose, the line value that if this were loaded into position, the first memory location that were available, then this is the value that these lines would take. So instead we've got load immediate the value 0. We've got then the base register, which sets really this to being the first line wherever it is in actual physical memory, and then saying, well, we need to store this at the position BR plus 10, which is, if we look down here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th line, actually the 11th, because we index and we start at 0, is this last line here. So at this position, where we've got the base register plus 10, is indicating that we're actually here. Okay, so you can see all the way through where this was being used. We've got the base register plus 10. We've also got an example here where we've replaced the use of this symbolic addressing, which is saying when we get to here, if this comparison results in false, sorry, we jump back to the loop. This loop here is the symbolic address. Well, this here says if this results in false, we jump to line BR plus 2. So we go 1 and 2, so 0, 1, 2, which is this line here, the LDM. So you can see they are the equivalent of each other, just using slightly different method of keeping track of where we are. And then in this final example here, we've got an example of absolute addressing. Now, I believe this to be a typo. I think it should be 200. And we begin at 200, line 200. We load the program in at memory location 200. And so we store 210, which is down here. So again, you can see where all of the instructions that use the base register plus 10 are now using the absolute value 210. Okay, and then this other example here where we use the base register, which previously used the symbolic value, we now use the absolute value 202. So when it gets to here, if this is false, we jump to line 202 and we continue through that loop again. Okay, so those are a comparison of the three methods, symbolic, relative, and absolute addressing. They all three achieve the same thing. They're just different ways of doing it. Obviously, for us, this is probably easier to understand. But for the computer, we would have to have this eventually. So part of the assembler's job would be to make those changes, make those adjustments to the code.